EMFAF is the European Maritime Fisheries Aquaculture Fund. It runs from 2021 to 2027 and is a successor to the EMFF fund, and it delivers on components of the Common Fisheries Policy, the EU Maritime Policy, and looks towards sustainable management of marine resource at a European level. EMFAF is jointly funded by the European Commission and the Irish Government. The Marine Institute operates the Marine Knowledge Scheme. Two particular programmes there of interest to us are the data and IT services and climate change in the coastal and deeper water area.
We're developing national capacity that will improve our understanding of climate change impacts on our coastal waters and on marine activities and on the marine environment. The focus of these projects relates to the building of national capacity in particularly skilled areas such as remote sensing and climate projections.
Climate service development at the Marine Institute are used to monitor the impacts of climate change in marine and coastal waters. So here at the Marine Institute we work very closely with environmental and fishery scientists, and we collect data from data buoys, which is in situ data in the water. We get information from satellites, and we use ocean climate models so that we can see what's happening into the future. And then we combine all this information and we develop products.
The EMFAF Sentinel sites are ocean climate monitoring stations in Irish coastal waters, mostly situated around areas of aquaculture activity. At these sites we monitor what we call essential ocean variables, or EOVs, such as temperature, salinity, dissolved gases and nutrients. These Sentinel sites aim to provide high quality data from all their locations. We currently have 3 designated sites. One is mature and has been sending back high quality data for a number of years now. A second site was deployed recently, and the third site is under development and is getting built as we speak.
The aim of this project is to enhance Ireland's capacity in the use of remote sensing technology from satellites to monitor the oceans around Ireland. There are many benefits to using satellite technology, such as we can take one single shot that covers a large area, and we can basically repeat this measurement over and over again to create a time series. Throughout this project we will be developing different satellite products with different European member states working on common issues of concern. We will also be collecting satellite validation data using in situ sensors from our national research vessels such as the Celtic Explorer or the Tom Crean. There are lots of different products that we will develop throughout this EMFAF programme, but one in particular that I would be interested in is monitoring phytoplankton blooms from space. So phytoplankton are tiny microscopic organisms that we cannot actually see with our eyes. We actually have to use a microscope to identify them, but when conditions are favourable and right in the ocean, these phytoplankton can bloom and create massive blooms that we can see from space. Majority of the time these phytoplankton blooms are a benefit for the whole ecosystem because they produce food, they absorb carbon dioxide and produce oxygen.
The aim of this project is to generate climate models for the marine domain, for the Irish exclusive economic zone, and to provide information for the marine sector. The climate models will indicate at the broadest level the level of change that we might expect in the ocean under climate change. The models will characterise Ireland's ocean state historically and under a number of different climate scenarios. And all of this data will be anchored in terms of how climate change impacts fisheries and aquaculture. The project can provide information to our key stakeholders in areas such as temperature, salinity, primary productivity, pH, the extent of ocean acidification, information on marine heat waves, for example, and how likely they are to occur in future.
By understanding climate change effects on the ecosystem and using climate models, which are computer programs that help us to predict what's likely to happen in the future, we can become better prepared and give the proper information to the public and government in order to be able to help people adapt in the future.